Hi guys, welcome you all to my channel Explore Edu to Teach. So the next topic in signal and systems that we'll be studying is the LTI system and the Fourier series. So this particular video will be talking about the LTI system, that is the linear time invariant system. Basically in this video, to just give you a brief, we'll be talking about the LTI system, about the properties included in the LTI system, and about the convolution of signal. This is a very important topic. That how do you deal with the convolution of signal in terms of the discrete domain and in terms of the continuous time domain. So if you are really interested in watching the video, do not miss to watch the video till the end, so that all the topics will be explained to you very clearly. The notes are present down in the description box of this particular YouTube video. So please download it from there. And do not forget to like, share, subscribe to my YouTube channel, the follow me on Instagram. The links are given down in the description box. There are many more videos which are going to come out on the similar topics. So do keep watching this space. So talking about the LTI system, basically what do you understand by a LTI system? So a system which satisfies proper, properly the property of linearity and time invariant is said to be the LTI system. So as the name suggests, LTI system is the linear time invariant system. So basically a LTI system satisfies the linearity and the time invariancy of the system. So if a particular system is linear and time invariant, the system is said to be a LTI system. Then we have the input signal, which can be x of t, x of n. X of t is the continuous time domain signal. X of n is the discrete time signal. Then you have the h of t, h of n. The h of t is basically the impulse function. So it's in terms of your time domain, and this is in terms of your discrete domain. And then you have the y of t and y of n. The y of t is the output signal in continuous time domain, and the y of n is basically the discrete signal. So basically a linear time invariant system will always satisfy the property of linearity and time invariance. Please be very clear with these terminologies. X of t, x of n, x of t is continuous time signal, x of n is discrete time signal in input domain, h of t, h of n is the impulse function, and y of t or y of n in continuous time or in discrete domain, the output response. I hope I am very clear to you. Okay. So if this x of t is unit impulse signal, y of t is the unit impulse response, my h of t will again be y of t upon x of t, a impulse response itself. So I hope I am very clear with this. So this is the linear time invariant system. So LTI system always satisfies the property of linearity and time invariance, in which you have this input signal, this output signal, and the impulse response domain. I hope I'm very clear to you. Please understand these terms very well. You'll keep on listening these terms always in the near future. So understand that h of t or h of n indicates impulse response, and if the input is unit impulse response and the output is unit impulse response, definitely my h of t, h of n will also be a unit impulse response. I hope I am very clear to you. Okay. So now what are the properties which are going to be followed by LTI system? The first property is the commutative property. That is, whether you do this particular sign is the convolution sign. A cross into a circle indicates a convolution sign. So y of t can either be x of t convolution of h of t, or either y of t can be h of t convolution of x of t. Any which way my output will remain the same. Hence it follows the commutative property. I hope I am very clear to you. The distributive property says my y of t will be equal to x of t into convolution of, your convolution sign should be coming, it is missing over here, x of t into convolution of h1 of t plus h2 of t. Next we have the associative property, in which your y of t is basically x of t convolution of h1 of t into h2 of t. So either you do the convolution of h1 of t into h2 of t and then convolution it with x of t, or either you do the convolution of x of t into h1 of t into convolution of h2 of t. So I hope I am very clear with this. This is the associative property. So be very clear with this. The commutative property says any one of the ways, x of t convolution of h of t or h of t convolution of h of t, x of t, any of thing will work if it follows the commutative property. Then the distributive property says x of t is into convolution of h1 of t plus h2 of t. And the associative property says y of t is equal to x of t convolution of h1 of t into h2 of t. So either fall to the convolution of h1 of t into h2 of t and then with x of t, or either to the convolution of x of t into h1 of t, that is convolution of h1 of t, and then that will get into convolution into h2 of t. So that is very important. Now we'll be talking about the convolution in discrete time domain. How do you do convolution in discrete time domain and how do you do it in a continuous time domain? I'll explain you the theory part, but when we solve a numerical, you'll have a better understanding of it. So please watch the complete video. The entire theoretical part and the numerical for the explanation of the theoretical part is been given in this video. So as I told you, we are talking about discrete domain. So we have x of n. H of n is the impulse function, that is h of n, and the y of n is the output function, but in terms of discrete domain. Hence my y of n is equal to x of n convolution of h of n. Now my x of n is basically an input signal, my h of n is an impulse response, my y of n is the output. So my y of n convolution property says summation k minus equal to minus infinity to infinity x of k into h of n minus k. I hope I am very clear to you. My y of n, which is the output discrete signal, is equal to x of k into h of n minus k, where k is equal to minus infinity to infinity. I hope I am very clear to you. So let us understand. I told you y is the output, x is the input, and h is the impulse function. In this, k indicates the value, the range of k is equal to the range of x of n. Don't worry, when we solve numerical, we'll try to apply this and we'll understand better. And the n value range will be the sum of minimum and maximum index of x of n into h of n. So let us try to solve a numerical and see what does it mean. So here they are giving you y of n. They're trying to ask you to find out y of n instead if x of n is this and h of n is this. Now you know the formula is y of n is equal to x of n convolution of h of n. The y of n is equal to summation minus infinity to infinity x of k into h of n minus k. So the k value basically comes from the range of x of n, that is 0, 1, 2, 3. And the n value basically comes from 0 plus 0 is 0 and 3 plus 3 is 6. So are you understanding how do we find out? So whenever x of n, h of n is given to you and they ask you to find out y of n, the y of n is equal to x of n convolution of h of n. And this y of n is equal to x of k into h of n minus k in summation, where k goes from minus infinity to infinity. But what are going to be the actual values of k and n is going to be as this. Now in case of my k value, the k value is going to go from 0 to 3 because k value is always the values of x of n. X of n goes from 0, 1, 2, 3. The value of the index of the values. And the h of and the n value goes from the, as we have written over here, the sum of the minimum and maximum index of x of n and h of n. That is, n value goes from the minimum index of x of n and h of n is 0 and 0. Hence 0 plus 0 is 0. And maximum value is basically, and the maximum value is basically 3 plus 3 is 6. Hence we have k from 0 to 3, that is the value, index value of x of n, and the n value is the sum of the minimum value of x of n and h of n and the maximum value of x of n and h of n. I hope I'm very clear to you. So let us start solving the question one after the other. I'll tell you how to solve one particular step. You can solve the other steps. So first we'll take the value of y of n as 0. So y of 0 is equal to k goes from 0 to 3 x of k into h of n minus k. My n is 0, that is 0 minus k is minus k. So what you need to do is start putting value of k one after the other. That is y of 0 is equal to x of 0 into h of minus 0 is h of 0 only, a plus x of 1 into h of minus 1, x of 2 into h of minus 2, and x of 3 into h of minus 3. So simply do it this way. X of 0, all the values are given over here. The x value starts from 0 to 3, h value starts from 0 to 3. So just substitute the value. For example, x of 0, h of 0 is 1 and 1. My x of 1 into h of minus 1. The x of 1 value is basically 1 and the h of minus 1 is basically 0, right? Because my h value starts only from 0. So my h of minus 1 cannot exist. So that's 0. Similarly, h of minus 2 is 0, h of minus 3 is 0, and try to find out the answer. Similarly, you have y of 1. The y of 1 is equal to x of k into h of 1 minus k. So my k value goes from 0 to 3. So put the value of k as 0, that is x of 0 into h of 1, because 1 minus 0 is 0. Now put k value as 1, x of 1 into h of 0. Put k value as 2, x of 2 into h of minus 1. And put k value as 3, x of 3 into h of minus 2. Try to put all this value and try to get the answer. In such a way, you can find out the value of y from 0 to 6. Here we have for 0 and 1. Then I've solved for 2, y of 2, y of 3, y of 4, y of 5 and y of 6. So this is my final answer. So please, the notes are present down in the description box also. You can download the notes from there and you can see how the steps solved. They are solved in a similar manner and you can verify your answer. So I hope I'm very clear with your discrete signal. I'll give you a short summary on it. So y of n was asked to you, x of n and h of n is given to you. So y of n is equal to x of n convolution of h of n. The y of n is equal to x of k into h of n minus k, where k goes from minus infinity to infinity in a general formula. But what about the scenario given over here? To find out the value of k ka range, the k ka range will be going from x of n range. So the x of n range goes from 0 to 3. So we have 0 to 3. And h of n range goes from 0 to 3. But the n range is the addition of x of n and h of n. That is 0 plus 0 is 0 and 3 plus 3 is 6. Then it is a very simple substitution. We'll first find out the value of y of 0, then y of n, y of 2, y of 3 till y of 6. So put the value of y of n as 0 and put the value of k as 0 to 3. Then just substitute the values and try to find out the answer. The values which are not being held, that's h of minus 1, we don't have the value for that. Just put the value as 0 and you can get all the answers. So please do check out the steps from the notes which are present in the description box. It will help you. The next kind of question is to basically solve the convolution in terms of the time domain signal. This is one of the most popular questions which comes in the examination also. It may be your university level exam or maybe a competitive level exam. So please try to see how do we solve such question. So determine the output response of this system h of t, which is equal to u of t, to an impulse to a unit to a input of x of t is equal to e raised to minus t u of t, where a is greater than 0. Try to find y of t. So the y of t is basically going to be x of t into convolution of h of t, and the formula is given as integral minus infinity to infinity x of tau into h of t minus tau d tau. And as I told you, basically my convolution follows the commutative property. So I can also write it as integral minus infinity to infinity h of tau into x of t minus tau d tau. Any which way I can solve the particular question because it follows the commutative property. So taking the first type, x of tau, that is replacing t with tau. Hence you have e raised to minus 8 tau for tau greater than 0. Why am I writing tau greater than 0? Because it's a unit in step response, and the step response indicates that it is always applicable for t greater than 0. Since my step response is applicable for t greater than 0, I am replacing my t with tau. My tau will be applicable for greater than 0. I hope I am very clear with this. And then my next thing is h of t minus tau. So h of t minus tau, ideally value is only equal to 1. I hope the h of t minus tau value is basically equal to 1 because it is a step signal, a unit step signal. The value is equal to 1. And as I told you, the step signal is applicable for t greater than 0. But since my t value is t minus tau over here, I will put my t minus tau as greater than equal to 0. So my tau will be smaller than equal to t. Hence, substituting the value, integral 0 to t e raised to minus 8 tau d tau, do this integration and you will get this as a final answer. So I hope I am very clear with this. So basically the output response of a particular signal is the convolution of the input response and the impulse response. That is, my y of t is equal to x of t convolution of h of t. The y of t is equal to integral minus infinity to infinity x of tau into h of t minus tau d tau. The x of tau is basically replacing the t with tau. Here we have x of t, here we'll have x of tau. So the x of tau is equal to e raised to minus 8 tau. U of t basically indicates a step signal which is applicable for t greater than 0. Since my t here is in terms of tau, it is tau greater than equal to 0. Then we have h of t minus tau. Now the h of t minus tau is also equal to 1 because it is a unit step signal. So in case of a unit step signal, we have one value because this value is equal to 1, and to get the range, t is always greater than 0 for a step signal. Since the t is equal to t minus tau over here, we have t minus tau greater than or equal to 0. Hence my tau is smaller than t. Just substituting the value over here of x of tau as e raised to minus 8 tau, h of t minus tau as 1 and 0 to t, and try to find out the answer. This u of t, it can only be used to indicate the time value and not for substituting the value over here. I hope I'm very clear and we can solve the question. Similarly, there is another question that I have taken up. Let's try to see how do you solve this question. Again, x of t is given to you, e raised to minus 4t u of t, h of t is equal to u of t minus 4. This is 4, okay. Try to find out y of t. So the y of t is the x of t into convolution of h of t, which is equal to x of tau into h of t minus tau d tau, and the integral goes from minus infinity to infinity. So the x of tau is equal to e raised to minus 4 tau. And since it's a step signal, my t is greater than or equal to 0. My t here is in terms of tau, so it's tau greater than or equal to 0. Similarly, h of t minus tau is equal to, here the value is 1 because we don't have any value of h of t given. It's only given in terms of step signal. Hence, a step signal value is considered to be 1. It's considered to be a unit step signal if nothing is mentioned. And again, this particular signal is applicable for t greater than or equal to 0. Since my t is equal to t minus 4, therefore it will be t minus 4 greater than 0. Now replacing my t minus 4 t with t minus tau, I'll get t minus tau minus 4 greater than or equal to 0. I repeat, my h of t is given as u of t minus 4. So basically it's a step signal, therefore my value is 1. Then I have the value of t minus 4. Now the t minus 4 is basically a step signal which is applicable for basically u of t applicable for t greater than or equal to 0. But since my value here is t minus 4, hence I have t minus 4 greater than or equal to 0. Now my t is been indicated by t minus tau. Hence I have t minus tau minus 4 greater than or equal to 0. Therefore my tau is smaller than or equal to t minus 4. Now what you need to do is just put the value of x of tau as e raised to minus 4 tau, h of t minus tau as 1, and the value of t will go, the value of tau will go from 0 to t minus 4. So just do the normal integration and you can try to get the final answer. So in such a way, we can solve all this particular question. I have tried my best to explain you about LTI system, about the property of LTI system, and about the convolution of two signal in terms of the discrete signal and in terms of the continuous time domain signal. So I hope I'm very clear to you. So please do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram. Please share this video to as many as people possible, because this is one of the most simplest concept of not only signal and systems, but will be applicable in many part of the study, because convolution is present everywhere. So thank you so much guys. God bless you.